In the first part of this tutorial, we saw how the list comprehension syntax is used in Haskell, and then we implemented our own version of the list comprehension in Java. So now that we have implemented the list comprehension, we're going to use that syntax to create the implementation of the Cartesian product. So if you haven't seen what the Cartesian product is, take a look at the last part of this tutorial where I explain everything about the Cartesian product and how it works and how it was implemented in Haskell. And now we're going to move on and implement it in Java using the list comprehension syntax. Let's get into the code. So now I want to calculate another thing. Let's just put public here. And I'm going to create another method because I want to do, now that I have the list comprehension logic, I want to do a Cartesian product. So I'm going to name it Cartesian. And remember, our Cartesian product takes as a parameter a list of lists of t, and it returns a list of t. So that's easy to write here. This takes, so it returns a list of t, and it takes a list of t. Just call it rate lists. Okay, so I'm not going to write a test for this now. I'm going to base, forgot the type parameter here, so it's t. I forgot, yeah, I'm not going to write a test for this, or could I? Yeah, I think I can. Like, if I go to our list comprehension test and I write a test saying void test Cartesian implementation test, and what I am, well, let's try the example that I have here with these three lists. So it's going to be list of list of, and we said 1 and 2, then 2 and 3, no, 3 and 4, and finally 5 and 6. So these are my input lists. And then we have our expected list is going to be list of, and this is going to be of another list, and we said it has to be 1 and then 3 and 5, and then it's going to be 1 and then 3 and 6, and the order may vary here, so we need to really work it out, but maybe the order is not going to be right because the order is important for lists, as you know. Then is 1, 4, 5, then it's 1, 4, 6, and then everything again but for 2. I think that's it. So I'm going to call this expected here, and I'm going to say assert equals, and in this case it's going to be expected and Cartesian, it's this comprehension Cartesian input. Okay, I'm going to extract this so I can print it as well, and we can look at the result in the console. Cartesian and Cartesian dot for each system out println. Okay, so now we have to implement the Cartesian function because we don't have it. So if we look at our logic here, we said that we need to handle the case of an empty list because at the end of the recursion we have an empty list. So I'm going to do that and say if we have a list which is empty, lists is empty, return list of empty list. Fine, this is what we wanted. So we're returning this as we have defined. Now we have to handle the case in which it's not empty. So it's going to be basically a list comprehension. List comprehension of, and so if we look at the syntax here, where is it? Actually we have it here. Here. So if we look at the syntax, we had to merge a single element with a list. But this single, yeah, so we'll have to to do it in Java, we'll have to do something like, so we'll take, let's just call it y and y's as we're calling it in the Haskell implementation. And so y, let's just leave it like this for now because we don't know exactly, we don't have the types yet because we haven't implemented the generators. So it's going from the first generator, we need the first list on the list of lists. So we'll use the first list. So we'll, to get the first list, we say where is our list? So this is the parameter lists, and we'll get the first one, which is basically, so this is how we get the first element of the list, which is a list of lists. And then the second element we said is going to be the Cartesian product of the rest list, the rest of the list. Remember, like we did here, where we mentioned the rest of the list. So in here, we're going to say, in this case, yes, I'm going to build lists stream. And I'm going to say skip one. So the first one will drop to list. So now we know that this is this one is going to be an element, single element, and this one is going to be a list of integers. So this is the first generator will basically generate integers because it's a list of integers. This thing is a list of integers. And the second generator is going to generate a list of integers. So how do we merge an integer with a list of integers? I'm going to do it like this. I'm going to create a stream of the first integer and a stream, and the second one, because it's a list, I can say stream directly. And then I can say stream.concat like this. And finally, the list, because I need a list. Now we have the whole implementation. And it really looks similar. It's not the same exactly, but it really looks similar to the one we had in Haskell. We have the merger, so how we merge the list, and we have the generator, which is the first element, and the second generator, which is the, oh, I forgot. I had to apply the Cartesian here. Now it's ready because I'm going to apply the Cartesian of this, and it's going to generate the combinations of the smaller lists. Okay, so if I run my test now, let's hope it works. Yes, it works. Excellent. So let's see what it was printed, and it's 135, 136, 145, 146, 235. So what we expected. So yeah, I'm very happy with this. I'm very happy with this syntax that we have created. Uh, it really helped create this function in a very easy way, and we can generate these combinations very easily, like the one we did here. Just create two ranges and then combine everything with the list comprehension. So extremely happy with this, and I'm happy to answer every comment that you have, guys. Anything, honestly. This was a short episode, but I really wanted to share this with you because I found it really interesting. Alright, so this was very interesting. I mean, I loved this episode. It was nice to implement this feature and to be able to create this syntax using these functionalities that are provided in Java 8. So I hope this episode has inspired you to create these kind of tools for yourselves, and don't settle with what the language gives you. You can always improve upon it. So I encourage you to be creative and use the language in new ways. And as always, if you like this video, smash the like button and leave a comment, subscribe, and I'll be waiting you in the next video. Bye.